I realize it's probably a good idea to throw in little summaries of what we've seen so far through each little stage of the series. I'm going to try to start doing this just to make sure that we are all on the same page. So let's look at some of the things we have seen so far in this series. We've started out by looking at, this is just the summary. Call this summary. I won't call this summary number 1 in case I start moving a few things around. So leave it like that. So things that we've seen so far, we've seen complex numbers, right? We've been introduced to complex numbers. You've probably seen them before you entered this series or before you entered your linear algebra course, but in case you didn't, they're not that hard to get a grasp on. It's essentially going to be a number system that's bigger than the realm of real numbers. That's bigger than the realm of real numbers, bigger than R. They have geometry, so they can be drawn on a plane. And they have the formula, which was going to be, I don't want this to look like it's a minus, so I'll get rid of that. They have the formula, which is Z, which will be your complex number, is going to be X plus I multiplied by Y. We know that X is going to be itself a real number, Y is going to be itself a real number, and I is going to have the property that if I were to be squared, it's going to be equal to -1. That's going to be the special property that you have. And to go about doing, multiplications and additions with these things, I'm not going to show you guys reviews of that. You're essentially going to just multiply them normally using I as if it's its own variable. Just leave I as its own. And then every time you see I squared, you just simply replace that with -1. That's essentially the trick to this. You're going to encounter that when you're dealing with multiplication and not with addition, obviously, because you're only going to have i's and no I squareds to begin with. We were introduced to the modulus. I might not have called it that, but we were introduced to the modulus. So the modulus of complex numbers is Z with these little bars around it, right? This will be the distance between 0 and Z, and obviously with Z having the coordinates X, Y. Go ahead and give that a little draw over here. Say we had our X, we had our Y, and we had our Z, which obviously had the coordinates X, Y. And we had, what color have we not used? Let's go with a nice orange. This here would be Z. So this is the distance from your 0 origin over here to the point Z. That's what it would be, what the modulus is going to be. And this would have the distance. So we can say would have the distance 0 if it were on the real number axes, which remember this was this one down here. The x-axis, if you will, was for the real numbers. And 1 if on the unit circle. We saw how we multiply by I and how that affects the plane. So we were introduced to, that was a problem. Sorry about that. That was a problem we looked at when we would have I to the power of k, what that would change for k. I'll include the 0 here. I didn't initially include it, but I showed you how to do it in that video. So how we would do it if k were to just be increasing like this. And essentially we were to go ahead and we went and we graphed this out, right? Because we would make a little table over here. So this would be our values of k. This is our values of I to the k. And whenever we're dealing with something like this, we want to find a pattern, right? And we saw that this was 4 periodic, which means every 4 values you would have a repeat. So I'll show you 5 values just to see that repeat. So what would happen if we have I raised to the the 0, right? If we have I raised to the 0, we know that anything raised to the 0 is going to be 1. So we'd have a 1 over here. Then if we had I raised to the 1, we know anything raised to the 1 is going to be that value itself. So it's going to stay I. Then we had I raised to the 2, and we know that our special property, the one that we saw up here, the special property that we have is that whenever you have I squared, you're going to have -1. So we'd have a -1 here. And then when we got to the 3, that's where things get a little bit tricky because you don't really see, how you'd go about solving this. But essentially, when you can just go ahead and split these up if you wanted to, right? So if you have I squared multiplied by I just to the 1, that would mean using this property over here and this property, we would get -1 I, and that would just be -I. So we'd have -I over here. And then dealing with the 4, right, the last one, to see that it actually does repeat, we can just split this up into I squared by I squared, which is going to be -1 times -1, which is going to be 1. And we see that we have the repeat of that over here. So we were able to go ahead and we were able to put that on this over here, and remember this is still going to be representing R, so we'd have 1 over here and we'd have -1 over here, we'd have positive I over here, and we would have -I down here. And essentially every time you multiply by I, you are doing a rotation of 90 degrees, if you will, around this circle. So that's one thing we saw, how multiplying by I were to affect something. It's going to multiply it, it's going to make it turn around like this. Then therefore, right, if you were to multiply by I 4 times, so if you multiplied multiply by I 4 times is I times I times I times I, which is I to the power 4. You will have no change. Due to the 4 periodic. Right? Every time you do 4 rotations, it repeats itself. So you can multiply by I 4 times without having any consequences. You're going to wind up in the exact same spot that you started off. What were some other things that we saw? I think that's essentially all we've really looked at so far, right? One thing also we saw, I didn't really mention this, but maybe I'll include another video in this. We saw fields, right? And fields are going to be rings where every non-zero value has an inverse. We looked at those inverses. So anytime you have the inverse and you're able to do division by complex numbers, we're said to be in a field. If you're only able to do addition and multiplication of complex numbers, we're said to be in a ring. So that's something that I don't feel is very important in terms of just right now. I'll probably make a bigger video on those things, so don't worry about that. So that's what we saw right now, and the rest is what we had from earlier videos. So we started up here with summary. So thank you very much for watching, and this was just a small summary. I'll try to include a few of these every few videos to make sure we are all on the same path. So if, nothing new was covered in this video. If you have any questions, leave them below. Any questions on any of this material that we've seen or anything you'd like me to cover later on in the series, leave below. I'll either answer you or make you a personalized video just for your question, and I'll link it to you. And if any of my videos have helped you out, please subscribe. It means a lot, and I will see you guys in a later video. Bye.